Okay, so in this video, what I'm looking at is the Z-table scores, and I'm looking at a particular example that I have on the data projector there, which states that assuming the cholesterol levels in adult Irish women that are normally distributed with a mean of 188 milligram per diluted litre at a standard deviation of 24. And for part 1, we're asked what percentage of adult Irish women have cholesterol levels above 200 milligrams per diluted litre. So for that particular situation, if we look at the normal distribution curve first, and I go to the mean, which is in the centre, always of the normal distribution curve. And for this particular one, the mean is at 188. Okay, which is said there in the data projector, 188 is the mean. We're looking for 200 or greater. So if we were to imagine that this number here was the 200, we're looking at this side of the normal distribution curve. So to solve that then, we know that the mean is 188. We know that the standard deviation, which is from the question, we're told is 24. And the value for x this time, because it's greater than 200, x will be 200. We're going to sub that into our z-table format. So z will be x minus the deviation over, or x minus the mean over the deviation. So that means that z is going to be 200 minus 188 over 24, and that's going to yield us a z-score of 0.5. We then go to the log tables. And on the log tables, we're looking to go to page 36 and 37. Now on page 36 and 37, it gives us the ability to read the z-table. So what you're looking at on the z-table is to go to 0. Okay, so we're looking at going to 0, and we're looking at going all the way across to 0.5. So we're looking at 0.00, 0.01. So if I want to go to 0.5, which is down further, I am getting our results then. So we're looking at 0.00 on the top line, we go to 0.5 on this line, and we're getting 0.6915. And that's on page 36 of the log tables. So our answer is that. So for us then to have the probability that z is greater than 0.5 or greater than 200, we're looking for this. Well, when you read the z-tables, it finds all the area to the left-hand side of the line. And we don't want the left-hand side, we want the right-hand side. So we're going to then have 1 minus our 0.6915. And what we're getting as our final solution then will be 0.3085. 0.3085. Changing that to a percentage, we'll end up with the following as our answer then, that 30.85% of Irish women will have cholesterol levels above 200 milligrams per diluted litre. And that's a very standard part 1 question. Okay, now I'm going to look at part 2. So part 2 says, what percentage of Irish women have cholesterol levels between 150 and 170 milligrams per diluted litre? So in this particular situation then, we're finding 2 z-scores. So our mean is still 188, our standard deviation is still 24, and our x for the first one will be the 150. We know that z is still x minus the mean over the deviation, which means we'll have 150 minus 188 over 24, which gives us that our first z score is minus 1.58. We'll repeat the process, but for the opposite number, which in this case is 170. Still using the same formulas. And that's going to give us minus 0.75. So we're going to look at this on the normal distribution graph, where the mean is still 188. We're looking at the numbers that are on the left-hand side of the mean because of 170 and 150 being less than 188. So we're somewhere here. So this would be an example maybe where 170 is, and then here could be where 150 is. And we're looking for that solution there that I've just shaded in. That's where our answer lies. So, again, we're going to go to the z tables. And we're going to read 1.58 and we're going to read 0.75. We can't read negative numbers on the z tables, so we're reading their positive version. So, the probability of z being greater than 1.58 from the z tables is what we're looking at. Now, I actually have a symbol incorrect there. Apologies with that because it's minus, and this symbol should be the way around. Okay, less than or equal to. So we go to 1.58 on page 36 and 37 of the log tables again. And what we're getting there as our value is 0.9429. Same process for the next one, where z is also, because it's a negative number, 0.75. We read that from the z table. It's very similar to the z tables over here on this question. And what we're getting is 0.7734. Okay. So what we're looking for then is the probability of minus 1.58 will be greater than z, less than minus 0.75. And that's going to give me our 0.9429 minus our 0.7734. And our solution in that case then would be 0.1695. Okay? That then means that our solution in a statement will be that 16.95% of Irish women have cholesterol levels between 150 and 170 milligrams per litre. Okay. Now, students usually get very confused with this particular area here. You might be wondering, well, why didn't he do 1 minus like what he did in the last example where he did 1 minus? Well, we have to remember that constantly the z tables read to the left-hand side. So when I was looking at the 170 mark here, and we calculated the 170 was this minus 0.75, which is here, we got this number. So I'm going to the left of that, which is why it's here. Well, instead of subtracting it from 1, we're subtracting it from the 150 gauge, which gave us the 1.58, which was the 0.9429. The difference of these two numbers is the final z decimal. And changing that decimal then to a percentage as the question is asked gives us our final solution. Okay, that's part 1 and part 2 of the question. We're now going to look at part 3. So part 3 is asking us about a percentage. So they're asking us above what value are the highest 15% of women's cholesterol levels. So for part 3 then, what we're looking for is to calculate the X value. So we're looking for this value here. Okay? We're not looking for the Z value as such. We're looking for the X value. So everything will stay more or less the same. We do not know the value for X in this question, so I'm going to leave it as X. The mean will still be 188 and the standard deviation will still be 24. And then putting that into the Z table formula will give us the following. That X minus 188 over the standard deviation. That will be the value for Z. Now if we look at this on normal distribution graph very quickly, what we're looking at is possibly some number over here which represents X. We're trying to find this number here, okay? That top 15%. So for us to calculate this then, I need to first work out what is the Z value based on 15%. So the Z value will be 1 minus that 15%, or 1 minus 0.15 would be better to state. Because this on the graph here represents this top 15%. And naturally the Z tables only reads to the left, which is why I'm subtracting from 1 to get this right-hand measurement. So that's going to give me 1 minus 0.15 will be 0.85. Again, we go to page 36 and 37 of the log tables. We're reading 0.85 from the Z tables, and what we're getting is that Z equals, back to now, 1.04. Now, I'm just going to explain that a little bit better, because it might sound confusing what I'm saying. So I go to page 36 and 37 of the log tables, and I'm actually looking for this in amongst all of these numbers. I'm looking for 0.85. Now the 0.8s are usually on page 36 across the bottom. And the number that is closest to 0.85 is what we're looking for. So we're looking for closest to 0.85. I can see that is 0.8508. So if I go to my Z table, the closest number I can see to 0.85 is 0.8508. Reading over to the left, that gives you 1.0, and reading vertically up, that gives you 0.04 on the Z tables. Which means that my Z value is 1.0 plus 0.04, which gives me 1.04. So you're kind of using the tables, as the students might say, backwards. You're not using them in this traditional manner. That's what's key. It can be quite tricky sometimes in questions to spot what number is closest to that. Which is why I advise students to always make some form of a sketch like this so that the examiner understands where you're picking that number from. And that was from page 36 of the log tables. So once we have the 1.04, I can now take that and let that equal my original formula, which allows me to find the value for X. So X minus 188 over 24 must equal the Z value, which I've just worked out from the tables. We do the very basic algebra on this to get X on its own. And what you're going to find there is that X comes out to be 212.96. So I just multiplied both sides by 24, added 188 to both sides, and that gave me 212.96. So what that means then in terms of the statement is that 15% of Irish women have cholesterol levels above 212.96 milligrams per diluted litre. So part 3 is an example where you're trying to find the value for x, which means you need to find the value for z, which means you need to take your percentage and you need to use the tables. But the rules still apply about subtracting from 1 because the tables read to the left of the line, we're looking to the right of the line, which is why the subtraction from 1 still applies. If that was less than 15%, then your line would be on this side, you would be looking for this, you would not subtract from 1. You would read 0.15, find a number that best represents that in the tables, that gets you your z-score, so it is this formula, solve for x. And in the final part of that question, estimate the interquartile range for the cholesterol levels. Now this is a very common question that comes up, asking to use the z tables to calculate the interquartile range. Now, so the first thing we have to calculate is the upper quartile. Now the upper quartile will be 75% of the data. So it will be the top 75%. So we're looking for a number that best represents 0.75 from the z tables. And what we're getting there is 0.67. So I go to my page 36. I'm looking for the number that's closest to 0.75, which for me is here. So we're looking for 0.67 from that, then 0.67. So the number on the z table is that's closest to 0.75, and you should make note of this with a highlighter on your page 36 because you will be asked for the upper and lower quartile range a lot. Is 0.486. 7486. It's on page 36 of the log tables. You'll find this number. When you read vertically from that number, you end up at 0.07. And when you read horizontally from that number, you end up at 0.6. Adding these two numbers, 0.6 plus 0.07, gives us our first z score at being 0.67. Now again, this is very similar to the last question. We're trying to calculate the value for x. We do not know x at the moment, so we're going to leave it as x. 188 is still the mean, deviation is still 24. We sub these values into our z-score table, or z-score formula. We already now know the value for z for the upper quartile has been 0.67. And again, just like in the last question, we can calculate the value for x, and we'll work it out using some of the algebra techniques. But the value for x there will be 204.08. That is your upper quartile calculated. Next, I'm going to calculate the lower quartile. The lower quartile is 25% of the data. So 25% of the data. So again, then what we need to do is go to the z tables and see can we read where 25% is. And when you do that on the z tables, what you will get is minus 0.67. Now again, I need to explain that before we go any further. Remembering that when we look at our normal distribution curve, we're all the time reading to the left. So when you read to the left for 0.75, naturally that's no problem because it's already going to be the majority of that to the left. But when you're reading for 25%, it's not straightforward. It's the opposite of 75%, which is the opposite of 0.67, which is minus 0.67. That's vital. Now, when we sub that in then, we're going to end up getting the following. So we're still using our same formula from the last part. So the z in this case will still be x minus 188 over 24, but that will equal a negative 0.67 because it being the lower quartile. And when we do the maths on that then, and we balance the equation, we get that x equals 171.92. That's the lower quartile. And again, this number here is milligrams per diluted liter, and again it's milligrams per diluted liter, which is the units that's from the question. So your interquartile range then will be the difference between these two numbers. Your interquartile range is when you subtract the lower quartile from the upper quartile. So you're going to have 204.08 milligrams per diluted liter, subtracting 171.92, which gives you your final answer as being 32.16 milligrams per diluted liter. Now, that's a very standard leaving cert question. I would advise that you watch this video and practice ones that are similar to it in the past papers. And it goes through everything got to do with reading the Z tables in the normal configuration, reading the Z tables in the opposite configuration, and also I'm going through here about the interquartile range, the difference between upper quartile and lower quartile, the positive and the negative, and then the solution at the end. Thanks very much.